Thanks, David. Okay, it's about time. Okay, let's go ahead and wind down conversations. Go ahead and start the lecture. So today we are officially leaving decision making, at least for now, and we're starting up the player modeling section. What does that mean exactly? Well, we'll get to it in a bit, but before then we have our typical announcements. Good chunk of them today. So quiz 3 is going to be on Friday. Nobody showed up in the lecture hall last time, so I'm just not going to be here because there's no reason for me to be here. It's not super comfortable. So instead, I'm just going to go sit on the Google Meet, just the typical office hour Google Meet. If you have questions, feel free to show up. They can either be on the quiz or they can be for the assignment or whatever. Quiz 3 is exactly the same format as the other two. I hope by now you figured it out. There will be a help session on Thursday, tomorrow, 5 to 7:50 p.m. in ETLC E2002. I have no idea where that is. I'm going to figure it out. If you want to come by for assignment 3 help, this is just going to be assignment 3 help. There's no extra like lab structure to this. There's no lab assignments, but I will just be there. I can walk around for everybody who has their laptops. I will look at your code. I will answer questions. All right. But it's entirely optional. You don't have to do it. This is a thing that probably is going to interest some of you. So I've added a makeup option for assignments. I didn't want to do this because it's extremely time consuming for me. But for some reason, the university decided to increase when people could jump onto the course, including like past the point of assignment 1, which is a wild thing that the university decided to do. And it's sort of negatively impacted the number of students. So because of that, now there's going to be a makeup option for assignments, just to be fair for everybody. You're not going to be able to make up all points, but you can make up to 7 out of 10 points on the assignment. So if you had an assignment where you got under 7 points, go check eClass. There's a description of how to do it. It's basically an oral exam. Assignment 3 is due on Monday. There's the normal 23-hour grace period. I think that overall there's been less panic about assignment 3, but I don't know if that's just that people haven't started assignment 3 yet. I truly don't know. I'm going to guess that we'll find out over the next few days. But if you haven't, I'd highly recommend starting assignment 3. It is technically simpler. I mean, technically in like a technical sense, like having like a deep understanding of code sense. It is technically simpler than assignment 2, but there's still complexity there. So I'd get started on ASAP. Also, you should have gotten an email about a midterm course survey. This is just a handy thing that you can do to give me some feedback, anonymous feedback, unlike the feedback that you have to do for the PQs. So if you have particular concerns or comments, please put them there. I will address them as well as I can for the end of the semester. Any questions on any of this? Okay, so quick review. What have we done so far? So far, we have covered spatial representations and movement strategies, right? So these were things like grids, path networks, and nav meshes. These were things like how do you go about changing your sort of smoothing, path smoothing, or other sorts of ways of adding steering or other behaviors. After that, we take a look at some decision-making approaches in terms of finite state machines, behavior trees, rules-based systems, and planning. And with that, we have basically covered almost everything you consider to be AI in a game, in all games. There are very specific individual instances where this isn't true, like for very, very specific games. But in like 95% of the cases, you now have everything you need to know to understand the AI of a game. Not its particular implementation, right? But the basic underlying systems. But we're still missing some stuff. So what element of most modern AAA games are we missing? Here's a hint. It has to do with the title of this lecture, player modeling. Who here has played Mario Kart? Yeah, there we go. Now, those of you who played Mario Kart, particularly those of you who played Mario Kart with a set of people with very different skills, have probably noticed something about items in the game. Can anybody describe that to me? People who are nodding their heads? Way in the back, yeah. Yeah, so the worse you are, the better your items get, right? This is a implicit way of doing player modeling, right? The game is automatically modeling what kind of player you are by your performance and is adjusting to make sure that you have as good a time as everybody else. This is a version of in-game player modeling, and it's one of the most obvious and the most simplest, which is why everybody sort of implicitly understands it. Even if you didn't before this, think, oh yeah, that's AI, I guess, technically. And the other side of this is data science. I literally just Google image search data science, and that's what it is. That's not what data science typically looks like. You're not like poking at purple screens like you're Tony Stark. There's also things like the Left 4 Dead AI director. Now, this is now maybe a slightly dated reference point. Did anybody play Left 4 Dead? Okay, there's some hands, all right. But there are other AI directors, and we'll get into exactly what those are in this lecture. Okay, so player modeling. What's up with this? Essentially, we can define player modeling as a set of approaches that represent or quantify the player's experience with the goal of improving that experience, okay? This is expressed very generally here because it can be either in the game or outside the game. Most of the things that are complicated and really interesting are going to occur outside the game because of the reasons we've talked about the whole semester around, you don't have computation for things happening inside the game. But there are some interesting stuff that do happen inside games. Basically what I just broke down, right? So it's either going to be within the game, like picking which Mario Kart item, or outside the game, like doing an analysis, analytics, and we'll do more of this sort of more complicated stuff on Monday. Today we're covering what I've been calling this sort of model-based player modeling, which is the sort of thing around having a particular model for how players are going to play the game, and then adjusting to the players based on how they fit to that model. So, general question. Can you think of the way player modeling impacts you if you play games outside of this sort of Mario Kart example? Any thoughts? Just done you. Let's see if we can grab somebody else. I like it when lots of people talk. Any thoughts? There's one really big, obvious one. Give you a small hint. Does anybody here play competitive multiplayer games? Yeah? You have a ranking in that game, right? I'm seeing some nodding. Okay, yeah, people are getting it now. So if you have a ranking in the game, that is implicitly a model of your behavior in that game, right? Is a model of that the game has of you and how you play the game. So, right, this is like, this may not be clear what this is. This is we'll get to this in just a second, but right, this is this notion of like competitive ranks in games. It's implicitly a model of who you are when you're playing this game. I have an example here from Overwatch that's maybe slightly dated now. Rip Overwatch. But if this is like Apex, this is Call of Duty, this is whatever, right? Pick your competitive game, League, Dota, whatever, Rocket League, et cetera, et cetera. You could go on forever. So there's a distinction that I'm making here between model-based and model-free player modeling. This might be a distinction that you've heard of in terms of reinforcement learning, but it's a slightly different distinction for player modeling use cases. So when we're talking about model-based, right, we're saying that we have a set of categories or value ranges to assign to some part of a player experiences. We'll get to examples of what we mean by this in a second, right? This is the model that we're talking about. We've pre-designed some notion of how we think people are going to play the game, and we're just trying to do matching, essentially. Versus model-free, where we're going to actually look directly at the behavior of the players without some predefined hypothesis, and from there, we're going to try to extract what are these types of players that exist, okay? So overall, we can sort of break down model-based player modeling into sort of four major types of models. This doesn't mean that they're the only types that exist. They're the only exact kinds that exist. But most other versions of this can be thought of as like derivatives or relatives rather, to this. So one of them is flow. This can be thought of as defining a space where a player's, a particular player is modeled as a point in that space. Then you have Bartle's player types. These can be thought of as like categories, ways of saying, okay, you are this kind of player, one of these types of player. You have ELO's performance rating. This is going to be a continuous value, often an integer, but it doesn't have to be, which is going to say you are this good. Here's your quality, right? You're just a number. And then finally, drama management. This is a wild one, very different than these other ones, but it's different between some target value and a current value. So it's a difference is the way that we model the player. Does this distinction largely make sense? We're going to get into specific examples for each one of these four in a second. So flow, easy peasy, really simple to represent. Here's flow. Not from Progressive, bad joke. So this is basically going to be a plot where we have skills, where we go from low to high skills along the x-axis, and then low to high challenge on the y-axis. Where we are on here basically represents the quality of the player experience, essentially. So if we're down here with we have high skill but low challenge, we're bored. If we have high challenge but low skill, we're anxious. And otherwise, if we have a nice sort of match for challenge and skill, then we're in what we call a flow channel or flow state. This was bigger in the 2000s. Everybody who worked in games was like, oh, you got to put the player in a flow state. That's not so much the case anymore, but it's still made use of. So for example, Mario Kart's example, the one from earlier, is essentially an example of trying to keep the player in a flow state, right? Matching them with appropriate challenge for their particular skill. We can think of this as skill as being represented now on the x-axis as place in the race, from, in this case, the worst place, whatever the last racer is, to the first racer, way over here. And then the challenge, right, is then fairly straightforward, right? This is the kind of item that they currently have. And by picking out the item that they currently have, we can try to force them to stay in this middle lane. Make sense? This just basically breaks this down into a little bit more detail. But I don't need to go in that more detail because hopefully it makes sense to you. But the essential of the question is, hey, what are we going to do about it, right? What item are we going to give them to try to make this challenge more appropriate? So there's flow is super simple, right? I can explain it to you in 2 slides. This is nice. It's nice and intuitive. It makes sense to people. You'll have this understanding, of course, games, challenge, etc. And it sort of matches player experience because it is, again, a very simple model. But there's some disadvantages here. You need to design reliable measures of player challenge and skill. This isn't easy. Mario Kart lucks out because their placement implicitly gives you this, right? But for games where it's not a racing game, there's much less of a direct way of measuring player skill. You can still do it, of course, but it's a more complicated function. It's also going to be more difficult for non-competitive multiplayer games. So if this is a PvE game, for example, right? We don't have the same sort of rankings of ability between our different players. It's also the case that this is only one element of the player experience, right? Just whether you're having a difficult time or an easy time doesn't actually tell us, are you having fun in the game or not? It's an indirect sort of representation of that. So to get a little bit more sense of, hey, there's more going on to a game than just challenge, we can get into Bartle's player types. So it was originally designed for multi-user dungeons. I don't think anybody ever use a multi-user dungeon? Yeah, way beyond your time. Oh, do you actually? Yeah, sweet. You can basically think of these as text-based MMOs, which is maybe a wild thing for you to think about, but back in the day, we didn't have graphics, so we had to make do. Basically, the original Bartle, which is named after Robert Bartle's player types, he originally proposed these based on D&D, and he had these 4 classes, these 4 types of players. There were killers who wanted to kill things, right? That's pretty straightforward, I think. There were achievers who are looking at getting achievements, of having great successes. There were socializers, people who just wanted to play a game to socialize. And finally, there were explorers, people who wanted to see new things in the game. So this is immediately going to get more complexity than flow, right? Flow just had a sense of challenge. It had no notion of well, why are you playing the game outside of that? What's your underlying motivation here? Which is this is trying to get at. Now, this is most often used in MMORPGs today. So often when you're behind the hood in the MMORPG, I have examples here of World of Warcraft, but that's extremely dated now. Technically, I should have more Final Fantasy stuff up here and maybe Destiny. But when you're designing quests in these games, designing new content in these games, they often try to design around some set of player types they think exist in their game. saying, okay, let's make sure that there's something for the people who are playing this to explore, people who are playing this to do fights, etc. Right, so World of Warcraft or other kinds of MMOs, you could have experience for killing mobs, right? You could think, okay, let's make sure that we have lots of mobs for them to fight. Let's make sure we have lots of quests or lots of like challenges for them to do. Let's make sure we have lots of places for them to go that are unique and interesting. And let's make sure that we have places for them to interact with one another. Now, we have an example of it actually being used in a game. So when we're talking about this side of things, when we're talking about it for design of like new content in an MMO, this is done not within the game itself, right? This is outside of the game. This is just based on designers thinking about these types of players, not actually reacting to you whatsoever. But there are examples of people trying to put this into a game. So for example, the original Dragon Age prototype, which yes, it looked like that, not great. Had a collaboration actually with the University of Alberta way back in the day to try to figure out like, okay, can we figure out what type of player you are in the game, figure out what's motivating you, and then give you more of that thing. Like have a system which is automatically going to adapt the game to you as you're playing it, like Flow, but in a much more complex way. So the basic idea was they're going to have, in this case, they broke down to 5 types. They had fighters, power gamers, people who want to just have like the best loot, tacticians, people who want to do creative thinking, storytellers who are interested in complex plot, and actors who wanted to take dramatic actions. And I'm missing a right side of that parentheses, apologies. The basic idea of how it worked is that each player was then represented as a vector, where they are now going to have an implicit notion of, okay, you're not just one type, everybody's going to be a mix of these types, right? So you can have points in fighter and method actor, for example. And then every action in the game, in the prototype, was tagged with one or more of these roles. And every time you did one of those actions, we're going to increment that value. We're going to update the value to say, okay, well, here's what we think you are, the kind of player you are. And then the system is going to choose the reward when we're actually at that state, when you finished a quest or whatever, based on whatever we think you are like, your maximal roles. So for example, right, let's say that player A has a vector that looks like this. We know nothing about them. They just started the game. Player then A asks for a reward for a quest, an action which is strongly tagged with power gamer, right? The value of 100, for example. We think it's really, really power gamer to say, give me a good item at the end. And the way that you can do this, right, is in the game, you can have the quest reward be part of like a conversation tree where you're sort of talking through it with an NPC. Player A now has a vector that looks like this, right? We just added 100 to it, very straightforward. And then later on, maybe the player will be offered more powerful items if their vector remains unchanged. Now, there's a problem with this, which is that we can get stuck in sort of believing that a player is of a certain type and then just keep on giving them stuff based on that without ever sort of exploring and getting different possibilities. So more advanced versions of this do exist where they try to like do some exploration, give you some random stuff as well to make sure that we're not like wrong and we just get wrong at first. So there's some advantages to player types, right? They can allow designers to understand the player base and they can broaden the appeal of a game, but there's some disadvantages as well. So different games genres need their own player types, which is tricky. So whales, right, are a type of player that people have identified in free-to-play mobile games. But it took a while for us to realize, hey, whales exist. People who want to spend like a lot of money in these free-to-play mobile games exist, and we should design around them, which is also morally icky. In-game usage of this model also is going to require a lot of extra knowledge authoring, like in the Dragon Age prototype example, where they had to tag every single action with what type of thing it was and how much they should get for it. This is why it didn't make it into the end game. Any questions on player types? Okay. With that, I've been talking for too long. It's time for a participation question. So I want you to pick a genre or a game you are familiar with. If you don't play games, just pick something that you're sort of vaguely aware of. And I want you to give me what are the major player types you think exist in that game. Then second part, I want you to tell me how the game could adapt itself to appeal to each of these player types. Okay? Take a few minutes. I'll throw this in the Zoom. Oh, hello. There's my mouse. Oh, Discord. Get out of here. Get out of here, useless Zoom things. Y'all really like reacting to things with the cowboy emoji, huh? Okay. There we go. Let's see. Let's zoom in here. Ooh, hello. Current window is too small. Oh no. What are we gonna do? Okay. Okay, so let's see here. So we've got choose your own adventure. That wasn't quite an answer because it was asking me, I was asking you to tell me the player types. So there's no player types listed here. And then they're saying storyline could be dependent on certain types of responses that are potentially tagged. So this is not an answer. You have not given me any player types. You have not given me how to adapt to those player types. You just repeated what I've told you. No points if this was a quiz. Terraria, okay, that's an answer, but again, no player types, but they've got player types here. So we've got builders, lots of unique blocks, furniture, and paint. So this would be how to design the game for this builder, but it wouldn't tell us how to adapt to builders. So if the game if Terraria saw you building a lot, how could it adapt to better suit you, right? That's the question. Explorer, interesting structures and biomes, again, same issue. Achievement, fighter, socializer, and Greg. Ah, okay. My favorite player type, Greg. MOBA, players who love taking objectives and teamwork in an online environment. So again, no player types there. The game can offer new challenges and maps whenever players can work together to win. Again, that's not adaptation. Sports games, FIFA. The opposing team, no, again, no player types, no adaptation. RPG, nope. RPG with Wales and free to play, nope. Portal, here we go. All right, now we're into it. So we've got a puzzle game here. You're making an argument that we have completionists, explorers, and socializers. You could have more achievements for completionists, okay. A less linear path for explorers and multiplayer experience for socializers. I'm not sure if these are things you're imagining the game is adapting to the player as, or just things that had to be in the game. I could imagine it either way, but this is the closest to the kind of answer that I would hope to see if this were a quiz. I play LOL, and there are a lot of power gamers. That's not what I asked, but I'm sorry for that. First-person shooters, no. Genshin Impact. Again, I asked you for not to do an RPG. Overwatch, it has 3 main types of heroes that you play. This is interesting, tank, DPS, or healer. So this wouldn't be an example of a player type, right? Because we just know which one you've picked. You're just picking to play tank, DPS, or healer. The notion of a player type is what is motivating you to play the game. So we could break it down further to say, hey, are you playing tank because you really want to play DPS, but the queue line is too long? Are you playing tank because you want to be protecting others? Are you playing tank because you want to just be like a big scary bruiser? Are you playing tank because you want to control space, right? These would be the kinds of things that you would say for player types. MMO, quest player types, quest driven, PvP driven, PvE driven. Okay. To people with quest player, they could add more quests. Yeah, okay. So this is a good answer. So it is very close to the answers that I've already given you. Dark Souls 3, and I'm not sure right now. All right. Okay. So a lot of issues with this. It seems like maybe you didn't understand player types. Hopefully you understand player types better now that I've sort of gone through some of these answers. Okay. No response, but I guess we'll find out in 2 weeks on the next quiz, huh? Here's my answers to give you a little bit more of an example here. So I picked Pokemon games, your standard Pokemon. And I said that there were these 3 types of players. You had tacticians, collectors, and anime heroes. Tacticians might want to be the very best there ever was and make the game more challenging then to adapt to them, right? They want to play, prove that they have the best knowledge of the Pokemon strategy so you can make the game more challenging to adapt to them. You have collectors who literally just want to catch all the Pokemon. So then you can increase the Pokemon spawn rates for uncaught Pokemon, right? To help them sort of achieve that goal. And anime heroes who wants to befriend certain Pokemon, right? And use them throughout the game. You can then make the game easier and have NPCs that actually comment on the Pokemon that are being used, particularly if it's unusual, right? Like, oh, wow, you're still using an unevolved Pikachu? That's crazy, that kind of thing. So this is more what I was looking for in that question. So let's talk about ELO's performance rating. So many of you probably thought, if you've heard the term ELO before, you thought it was actually the letters ELO and it stood for something. That's not true. It's this guy. That's Arpad Elo. There he is right there. So he's just a guy who came up with this algorithm for, in this case, ranking chess players. Here's the original algorithm. It's super simple. For each win, add your opponent's rating plus 400. For loss, add your opponent's rating minus 400. Divide this sum by the number of played games. That's it. That's ELO's performance rating. If you like, there it is in a formula. Super easy, right? Now that might seem like, well, this is simple, but this was revolutionary at the time because there was no way previously to think about ranking people who played chess against one another in an objective, semi-objective manner. Previously, this was all done by like, oh, that person seems pretty good. This is all right. This seems pretty good at chess. Now, there is confusion, as I've sort of gestured at, around ELO rating naming confusion. Many games do not make use of this exact rating algorithm, but you will still hear people referring to ELO rating or ELO hell, which is to say that they're sort of stuck at a lower skill rating than they think they ought to, because clearly they're the best in the game ever. This phrase then generally is referring to any algorithm to update player skills or model of player skills given wins and losses, along with prior player skills. So it's basically skill-based matchmaking, right? It's the original inspiration for that. Now, most of the time for particular games, this is game dependent, right? How much you get for a win, how much you get for a loss, and whether there's particular other things that are getting you points or whatever towards your skill rating in the game. So somebody mentioned Overwatch a second ago, right? Originally, when they first had their skill-based matchmaking, they had it based on, for like healers, how much healing you did, and tanks, how much damage you blocked, and things like that. But those are easy things to cheat at, and so they ended up removing them. They ended up changing their model of player skill, right? That's the kind of thing that you do for this. Okay, so ELO rating or skill-based matchmaking generally, advantages, it generally requires very little design or authoring. In fact, if you author more things, like saying you get points for doing certain actions, you often break it. And there's ways of then cheating the system to get higher skill ratings. Really, what you want it to be is as close to and even you win, you get points, you lose points as possible for it to be objective. And it does a surprisingly good job of keeping competitive games fair. That's because it's in use for like 100 of years or so at this point. Now, here's some disadvantages. Players do not like seeing values drop. Players say what they want is a fair game, but actually subjectively, if you sort of test this out, players really want to win roughly 70 to 80% of the time. And I think that's fair. But that doesn't work, right? If we're trying to put you with people who are at your skill level, you're going to win and lose 50% of the time. And that means your number is going to go up or down a lot. But what people want is they want numbers to go up. People feel good when numbers go up. So the trick to this is that many games have true hidden ELO ratings. They hide the actual value of your skills from the player, and they just show you numbers that go up over time because that's what makes people feel good. It's also then limited to competitive experiences, right? As close to single players versus each other as possible. As soon as you add in multiplayer, it's really hard actually to identify, hey, who was responsible for a win or a loss. Now, if somebody plays enough, it'll average out, and it's fine. And people, most of the time in games, just sort of leave it to that. But it really only makes sense still when we're comparing players to other players. As soon as we get into something where we have like a PvE environment or something like that, this doesn't make sense and it's not appropriate to apply. But in PvP, it's quite good. Okay. The final one of these that we're going to cover today is the Left 4 Dead AI Director, or AI directors generally, but this is just a specific example. So we're going to take a look. Warning, some more blood and zombie violence. Give me a second. Hello? Okay, it opened it in a window and then it disappeared. A mystery. Let me close some of these things. Maybe I'll just try from here. Sorry, give me a moment. End the show. I'll just copy and paste. That didn't seem to want to work. Once again, there's lots of fun zombie noises in this video, but we're not going to listen to them because of the horror that is the audio in this room. As a reminder, this is the game that we originally were talking about when it came to like dialogue and talking about examples there. So occasionally you're going to see like little dialogue prompts, and you know how that system works now. But let's take a look at this. So this is Left 4 Dead. It's a team-based zombies. Oh, now it's an ad for Elion. Who is this? All right, let's go back. So this is a Left 4 Dead team-based zombie shooter. You can see we're currently wandering around this apartment, just shooting these passive zombies, right? Now there's this thing happening. Every zombie that you're killing just so easily is updating a little counter in the back to say, oh, this game is really easy. We should make this game harder. Every time that's happening, we should make this game harder. We should make this game harder. And then check the door. Uh-oh. Uh-oh, uh-oh, uh-oh. And, you know, a mass of zombies show up out of nowhere, spawned in by the game to try to make the game more exciting. Because it was sort of, you know, a little passive there for a bit, a little boring there for a bit. And we want to keep the player at a certain level of intensity. So here's the way that worked. Here's the system that was going on under the hood, so to speak. So this is essentially a concept of drama management. Many of you will have seen this sort of triangle before, yeah? In like a literature class, for example. For those of you who haven't, super simple. It's a notion of sort of Aristotelian drama in stories. We're going to start with exposition, kind of boring. Then we have rising action, things get more and more intense until we hit a climax, and then falling action, things calm down, and then denouement. This is like a very standard story setup. Watch any Hollywood blockbuster and you're going to see this in action, right? Literally, these days, for whatever reason, every single movie has to end with like a climactic battle, right? Every single movie. I don't know why. But anyway, the basic idea is that we have some notion here of intensity over time, right? This is a little bit distinct from flow, where we were looking at, you know, skill versus challenge. There's no notion of time here, but there is a notion of, as we progress, we want this sort of changes in intensity. So the Left 4 Dead AI director, what it was doing in the background was it was constantly trying to measure this sort of player intensity. How intense was the situation for the player? Intensity would increase when you were attacking or being attacked. When you were hit, right, intensity was put to the max. When you were incapacitated, rather, players were slowly dropped in intensity when nothing else was happening to be able to reset that intensity. And then, you know, you'll note this is a lot like challenge and flow. It's a particular model for how we can model challenge. They're just calling it intensity in this book. If you want, there's a whole blog post by the great Tommy Thompson on this. The Left 4 Dead AI director then had 3 modes, which is related to this sort of Aristotelian notion of drama management. So there's build up, where the AI director is going to attempt to take actions in the world that will increase tension. Spawning in new enemies, decreasing the amount of health items available, spawning particularly difficult enemies, or even changing the level design itself to make it more intense. Peak then was when the intensity reaches its max. That means the director is going to stop spawning the enemies, is going to stop making these changes. And then finally, there was the relax, where the director is actually going to do the opposite of the buildup. The director is going to spawn helpful items, right? Or alter the player path to make things easier to decrease tension. This is literally modeled, in this case, as an FSM, right? Build up, peak, relax. And it's a cycle. There's only one, you can only go in this cycle throughout this FSM. It's fairly straightforward. Now, this was actually super popular. It was super well received by players, and it's one of the reasons why many of you were still playing Left 4 Dead, even though it's extremely old. And because of that, there's been a lot of people who have been trying to replicate that. Other games using AI directors, though not always super well executed, like Remnant from the Ashes a couple years ago, and Back 4 Blood, which literally came out like, what, 2 weeks ago at this point? I think something like that. It's an obvious sort of spiritual successor to Left 4 Dead, though it's not super well reviewed. I don't know, each their own. But it still has an AI director in it, even though that AI director, as Escapist here says, lacks tension. So quick summary of drama management. Advantages, it can be effective and highly praised, right? Like critics responded really, really strongly to the AI director from Left 4 Dead, and players did. That's why the game has had such a long history to it, of people wanting to keep playing the game over and over again, because it makes, even though the space is not really that procedural, it makes its experience unique. It also gives players another level of strategy. So people who are like really good at Left 4 Dead, like people who are trying to speedrun Left 4 Dead, will actually talk about trying to manipulate the AI director. So we'll talk about, okay, we don't want to kill any zombies here. We don't want to take any damage, because we know that if we do, the intensity is going to wrap up and we're going to get a big climactic moment, which is going to slow things down a lot. So they're actually on the secondary level, sort of in a battle against the AI director as they're trying to play the game. It was pretty cool. Now there's disadvantages here, right? It's a fair amount of authoring. It's going to be less than player types because we have to define particular players, but it's more than flow, certainly. And it has all the downsides of FSMs. So if we have these three kinds of states, right, then we can get caught in specific states when specific things happen if we're not aware of it. It's also the case that we can only do the things that we can do. So for example, I don't know this is true, but one thing that I think is true about Back 4 Blood, which I might eventually find out at like a GDC talk or something, is that they don't have this sort of decreasing tension state. Or if they do, they have a transition that only keeps the player in there very shortly, which means that it's just constant tension and there's never any release of that tension. There's never any moment to relax during a contrast to the tension as it comes back again. That's one of the reasons people aren't finding it as fun. So again, you have to think about the states that you want ahead of time. Okay, overall summary of player types. Generally, in terms of authoring burden, which is a very common quiz question that I might ask, we're looking at things like player types requiring the most, right? Especially if we're going to use them in a game. If we're not using them in a game, okay, it's just a list of like n things, or n is a number of player types, no problem. But if it's in a game, we have to have a lot of authoring to adapt to that. Then drama management, because we have to have some measurement of intensity or challenge or whatever. And we have to have a whole AI system for adapting to the player based on that. Then we have flow, right? Okay, we have to have one measure of challenge, and we have to have a simple way of adapting to that. It can get more complex, but if it gets more complex, we've entered into drama management land, right? And also, there's a distinction here in terms of time. Flow doesn't care about time, drama management does, but that's just an added complexity. And then finally, LOS ratings, right? In an ideal world where we just have to worry about wins and losses, this requires extremely, almost no authoring whatsoever, no extra authoring. If we're going to do more complex things like skill-based or action-based ELO rating increases, then of course it's going to require more. But this is a general sort of ranking here. Now, in terms of the ability to use outside a game, really we're only looking at player types, right? As like a design tool. You can use some of these other things like flow, for example, can be a thing that you're trying to go towards, saying let's get the player in a flow state, but you can't really use it in the same way outside of games, right? During the design process is really what I mean here, when we're making something new. Ultimately, these models, this is a little bit of text, but it's important. These models are built from a designer's perspective. So this is the designer imagining, right, what kinds of players exist, what kinds of, experiences do we want players to have? What does it mean for a player to be good at the game, right? These come from the designer, and they're therefore subjective. Now, this could be still really good because the designer could have a lot of experience, or they could luck out and like have a good understanding of the players of their game. but it's not going to be necessarily the reality of that behavior. It's not going to match the objective facts of what is happening in their game. So on Monday, we're going to cover how you can go from literally the logged events, what players are doing in your game, to models of their experience in that game. All right. Cool. Okay. And then we've hit just on time. 10 minutes remain in terms of quiz 3 review. So as per usual, I'm going to do the same distinction that I did for quiz 2, which is to say that I want you to be able to run or implement or sort of do the algorithm for behavior trees, forward planning, backward planning, or chaining, I use both terms, partial order planning, hierarchical task networks, right? You should be able to do those things. You should understand those things deeply enough. If I give you a question and I say, run the algorithm given this setup, you should be able to do it without having to say like, hey, so is it possible to be in like more than one state at once? That doesn't make sense with us, but you know what I mean. I want you to remember or just know about today's player modeling methods. There might be like one multiple choice question or something like that, but generally the bulk of that will be on quiz 4. And the other decision-making approaches. So I want you to remember, you know, the things we've talked about already. We're talking about rules, we're talking about FSMs, we're talking about MCTS, basically. And then path planning approaches, we're talking about A-star, greedy, APSB. Give you a high level of sort of remembering what's up with those. That's really all you're gonna need. Okay. Any questions on any of those topics? Also see the Zoom chat, because the Zoomers, for whatever reason, are more willing to ask me questions. But not right now. HTN, could I get a little review? A little bit of review. Sure. Let's see here. What's the easiest way to do this? Did it mess up my camera? Is my camera still on? Let's find out. That's not my camera. Nope. My camera is totally dead. Yeah. Zoom hates it, you know? And if I stop sharing and resharing, yeah, it just truly doesn't matter. Let's do this. Let's go over it by opening back up HTNs. Doing a quick check this way. So if we're talking about like a little review of HTNs, right? The important things to remember here are that we're going to have multiple levels of actions that we can accomplish. This goes all the way down to atomic actions, right? These are the simplest things you can do. This is like actually moving one step forward, one step back, etc. But it goes up to more an arbitrary number of hierarchy going all the way up to the top. You know, we've had here this example of 3 layers to it, of saying there's a goal and there's these squad behaviors that can allow you to achieve that goal, and then you break down the squad behaviors into subsets from there. But this can go arbitrarily down and arbitrarily up. The key here is that you only need to plan. You actually need to like run, for example, forward planning when you actually are at this lowest level. When we say, okay, how do we achieve this goal? As opposed to saying, how do we achieve this goal from just forward planning alone? That's sort of the distinction here. If we take a look at, here we go. Forward planning, for example, forward planning was sort of this step, right? Where we say, okay, we're going to have some goal, like we're going to have the key, for example, and then we're going to look at every single possible action you can take, and just using A-star or greedy or something like that, select a single one of these and then continue moving forward from there. It was basically the same as path planning, but we're also going to have actions in the mix.
Professor?
If this was like, if we were going to do this, this environment with an HTN instead of just forward planning or backwards chaining, and I showed you both, what we would do is we'd probably have like a couple different higher level tasks. Like one would be get item, right? Another could be, you know, move boulder. And the final one would be, we'll actually just get item again, right? So then if we were doing the high level goal of like have the item, have the key, We could have a lower level goal of get the gauntlet, then move boulder, then get key. And then finally, we would decompose from get gauntlet to an actual low level plan of the movements to that gauntlet and picking it up, then move boulder, then get key, etc. Yeah, question in the back. Did I accidentally turn that off? My bad. It was just the things you've seen before, right? So this was the example of forward planning. This was me going over the hierarchical tasks. So it's really not that big of a distinction from what you've seen before. No secret new information. Also, where did my chat window go? There it is. I like that no one was willing to say it. That's great. Prisoner's dilemma. Who is willing to speak? Any further questions? Yeah.
So would backward planning literally be the opposite of forward planning? So start with like get key and then
So you can't use backwards planning with HDMs.
Yeah.
So you wouldn't do get key and then get move boulder, right? Backwards planning only works at the lowest level of actions. So if we're doing backwards planning, backwards chaining, right? That looks like saying we're going to start from, we want to have the key, which means that the player has to be at the same location as the key and has to just have used the action get key, right? Get item. But we don't know anything else about the world. And as we go backwards, we're going to have to define things about where objects are. Does that make sense? So we don't start with like a full state representation in the same way. We have to have a way of saying, we don't know some things that are true about the world, right? They're just unknown to us, which is why I have those question marks there. And an actual implementation, right? You might be using, we talked about like facts when it came to the rules-based systems, like knowledge bases. You might have a list of facts. In addition to like saying, boulder is at position, you could have an extra thing of saying, oh, boulder's position is unknown, right? And if it's unknown, we can define what it should be by doing the rules backwards, right? Which is to say, initially, we know this is true. Player has to be here to be able to get the key.
Yeah.
From there, we know that to have gotten the key, player would have to have moved from this spot, right? Because there's no other way the player could have moved. So there's only that one thing that could have been done. From here, to have moved here, right, we're introducing, to use the language of like partial order planning, a conflict or a flaw. And from there we can say, okay, well, if Link here must have been in this position after being in this position, or before in this case, because we're going backwards, then the boulder would have to be either here or here. We'd pick one at random in this case, or if we had some heuristic, we'd pick one according to that. And then we'd continue to backwards plan from there.
Okay, gotcha.
Does it make sense?
Yeah.
Okay. But our goal sort of here is to get to the initial state, something that looks like that initial state. We just don't know what the full end state actually is until we sort of defined it by going backwards to that initial state.
Gotcha.
Yeah.
Can we do like forward plan and backwards plan and meet in the middle, or?
You could, but there's generally no need to.
Okay.
So we broke down, like, it's a good question. Oh, Sam spoke, but apparently my audio just wasn't on. In fact, it's not letting me have any audio, which is pretty cool. Sorry, Sam. Didn't mean to discount your bravery in speaking in a Zoom call. Let's see, where did I do the comparison between back planning and forward planning? Here we go. So forwards planning is helpful in situations where we have inconsistent actions, where we have a probability of something happen versus not happen, right? Then we can sort of have this like branching thing where either it's going to happen or it's not going to happen, or whatever the number of possible outcomes probabilistically are, we can handle that, right? Now this can lead to a large amount of branching, which is a problem, not great, but it's helpful in those domains, situations where that is true, we have those rules. Backwards planning, on the other hand, is going to be really fast, where we don't have any actions that negate decisions, and we don't have any inconsistent actions in this way. So really it's domain based to say which of these are appropriate to apply. If we were in let's say we were in, the domain with inconsistent actions and we tried to do the thing you just said, right? With backwards planning, we very quickly just fail, right? Unclear when, maybe we get 50% of the way, maybe we get 90% of the way, but maybe we get like 5% of the way before we fail. At which point forward planning would have to make up the rest of that distance, right? So we don't really get any benefit out of it. Does that make sense?
Yeah.
Anybody else? Okay. As per the usual, I will stick around here if there's questions that people have that they don't want to ask in front of the rest of the class. I will not be here in the room on Friday, but I will be on the Google Meet. So you can ask me questions there if you have questions on the quiz or the assignment. And I will see some of you tomorrow evening.
Hi, I have a small question about like, the custom state for the custom ghost in assignment 3.
Oh, sure.
Are we allowed to like sort of speed up the ghost in like a situation?
So you have 3 actions in FSM agent that impact the ghost speed, and that's all you can use.
But
There's no way to otherwise change the ghost
are
speed.
we allowed to use those? Or,
Yeah, you can use anything in FSM.
Okay. And are we allowed to have a state where it's dependent on like another ghost being there? Like for example, if this only happens if Pinky is there.
You can, but I wouldn't recommend it because I'll be testing it with a variety of situations, but like that situation is not guaranteed to be one of them.
Yeah. Okay. And about player types, I kind of just want to know if I got the right idea here. So I kind
Sure.
of thought of this like after the practice question, but like Fallout's karma-based system, where it's like evil, neutral, good, and it's sort of like changes the story because of that, and it also like spawns different enemy types because of that.
Sure. So like, yeah, and then like these kind of like Paragon and Virtue or whatever in Mass
Yeah.
Effect are similar.
Yeah.
Sure, that's like a very simple type of player type of saying, again, it's about motivation.
Yeah.
Like, we're going to assume you are motivated to do good versus we're going to assume that you're motivated to like do chaos.
Yeah, exactly. Okay.
Yeah, that works.
All right, thank you.
No worries. Okay, bye people on Zoom. I have to stop this. Oop, there we go. Bye people on Zoom.